Now I have a base one I put in here right now, which is 192.168.150. Now, so I hit enter, and what it's going to do is populate our actual binary for that. So our first octet, when I store the number down here so that we can actually reference it as well. So it's 192. So can 192 go into 168? Yeah, or 128? Yes, it can, with a remainder of 64. So that comes in and does 1. Right, so the binary for that is 11000000. Okay, so that's why I made this chart right here, so you can easily see it and break it down. Alright, so in this video what we're going to talk about is IP address binary, right? So what is the binary of an IP address, and how do you actually calculate that, right? What's the mathematics behind that? What is the way the system works? And why do you want to even know that, right? So multiple reasons why you do want to know that this day and age is because of the simple fact that we talk over TCP IP. So we need to understand the way that the system works for IT/OT convergence, right? IT, which is information technology, and the OT for operations technology, which is basically the PLCs and the HMIs that we work with daily, right? So with us understanding the way, and when breaking down the binary of an IP address, we can break down the binary of many different things like subnets, right? But let's go ahead and talk about the binary. And I have an example up here of 192.168, and let me just talk about this real quick of the environment we have. So I did build an HMI application for this, and a very simple application so we can enter in multiple IP addresses and test the system out, let it pre-do all the calculations for us so that we have the outcome of that. So we're going to do a lot of testing in here, but first I want to break down the understanding behind the example that we have, right? So we have the example that we're running 192.168.0.1, right? So we're going to do each octet at each time, right? So let's talk about the way this is done. So the very first octet, right, is going to be 192. We need to understand the way that works. So first we need to understand the way binary works. It's a base 2 system, right? So with the way the base 2 system works, we're going to have each one of these is going to be to the power of 2. Now the reason we have a number 1 right here when we start off with number 1 is because any number to the power of 0 is going to be 1, right? So we have a 1 right here, and then we have a number 2. We have 2 right here, to this 2 to the power of 1, and then a 4 right here because it's 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. So that's how we actually get the numbers that we're talking about here. Let's scroll back up here so you don't get that I actually jumped down. So let's come back in here. Now, how do we actually do the math behind this, right? So let's come down here and talk about this. So first, can 192, right, which is our first octet, can 192 go into or is it equal to or greater than 128? Yes, it is. So that would be a 1, right? It would be a 1 instead of a 0. With the remainder of that, so let's talk about the math behind that. So let's talk about that. So with 192 minus 128 leaves a remainder of 64. Can 64 go into 64? Or is it equal to or greater than 64? Yes, it is. It actually cancels itself out, and that's 0. So the binary of this 192 is going to be 11000000, right? So it's 8 bits. Okay, keep that in mind. So the next example we're going to do is 168, right, which is the second octet, right? So with the second octet, we have to ask yourself the same exact thing. Can 168 go into 128? Is it equal to or greater than 128? Yes, it is. Okay, so what is the remainder of that, right? So we're going to do the math behind that. We're going to say 168 minus 128 is going to leave a remainder of 40. Okay, can 40 go into, is it equal to or greater than 64? No, it's not. But is it equal to or greater than 32? Yes, it is. Okay, so that leaves, that does 40 minus 32, which leaves 8. So is 8 a remainder? Is that going to be equal to or greater than 16? No, it's not. So at that point in time, is it equal to or greater than 8? Yes, it is, and that cancels itself out to a 0. So the end result, the binary for 168 would be 101010000. So that breaks down. Now that we're going to get into the really simple ones right now, the next one is 0. So can 0 go into any of these numbers? No, it cannot. So the binary for that is all zeros. It's 8 zeros. So just to kind of give you a base understanding of how the way the mathematics works. Now 1 is very simple. Can 1 go into any number but itself? No, it can only go into itself. So that's going to leave the binary code of that is 00000001. Okay, so keep that in mind. Now this gives the whole example down here. So the actual thing your computer sees, right, when we're talking about the different layers and the way they pass things on. Now keep that in mind too, as I'm going to talk about the way the IP classes are. That you have class A, you have class B, you have class C with their IP addresses. Now in automation and the way we do things, we're going to be class C. And again, that's just the way things are broken down, right? So the way things are broken down, we can talk about that in a whole different video, but for the sake of what we're doing right here, we're going to talk about the way the mathematics is, right? So the way the math is being that binary is a base 2 system, we have these numbers right here, and we just basically have to ask ourselves, does the octet we're looking at, does it go into these numbers, right? Is it a yes or no, a 1 or a 0? Is it binary? That's basically what we're talking about right here. So after we've covered this base principle or example number 1, let's jump into our HMI application. All right, so let's come over here to our HMI application, and I did build this so I can move it around, and this is the code behind it right here. It's basically coming in looking at each octet, right? So it's coming in looking at each one. Real simple logic. So we clear out our system. Now I have a base one I put in here right now, which is 192.168.150. Now, so I hit enter, and what it's going to do is populate our actual binary for that. So our first octet, when I store the number down here so that we can actually reference it as well. So it's 192. So can 192 go into 168? Yeah, or 128? Yes, it can, with a remainder of 64. So that comes in and does 1. Right, so the binary for that is 11000000. Okay, so that's why I made this chart right here, so you can easily see it and break it down. Now the second one we had is 168. So can 168, is it equal to or greater than 128? Yes, it is. So that's a 1. Is the remainder equal to or greater than 64? No, it's not. Is it equal to or greater than 32? Yes, it is. That's a 1. Is it equal to or greater than 16? No. And is it equal to or greater than 8? At that point it is, and that's the end of it. So the binary of that, the second octet, right, is 10101000. Alright, so the last one we have, or the third octet we have, is 1. So 1 is pretty much, we went over that in the example, is going to be 1, right? So the next one we have is 50. Okay, so 50. Can 50 go into 128? No, it cannot. Can 50 go into 64? No, it cannot. Can 50 go in? Is it equal to or greater than 32? Yes, it is. And the remainder, is it equal to or greater than 16? Yes, it is. Equal to or greater than 8? No, it's not. From the remainder of what all the math we've done so far, is it equal to or greater than 4? No, it's not. Is it equal to or greater than 2? Yes, it is. So the binary for the fourth octet, right? The fourth octet is going to be 00110010. Now let's do something completely different. Let's do 10. Let's do 15. Let's do 77. And let's do 254. Now generally you wouldn't go 254. And I put a little thing over here so that I can go off and not highlight everything. So let's load that in there. Okay, so we've loaded that in there, and we're going to now calculate our binary. Okay, so the very first thing we noticed, our first octet, right? Can it go into 128? Nope. Can it go into 16 or 64? No, it cannot. Can it go into 32? No, it cannot. 16? No, it cannot. Can 10 go into 8? Right? Is it equal to or greater than 8? Yes, it is. So that's a 1. Is the remainder of that, when you minus 8, equal to or greater than 4? No, it's not. Is it equal to or greater than 2? Yes, it is. So 8 plus 2 is 10. Right? So the binary is 0, 0, 0, 0, 1, 0, 1, 0. The second one we had is 15. Now, in this atmosphere, we obviously tell that's not 128, 64, 32, 16, and now it is equal to or greater than 8, so that's going to be a 1. Equal to or greater than 4 for the remainder, yes it is. Equal to or greater than, for the remainder, equal to or greater than 2, yes it is. And 1, it is as well. So the binary for 15 is going to be 0, 0, 0, 0, 1, 1, 1, 1. Now, let's talk about our third octet, right? Which is 77. Okay, so when we come in here, we can look at our third octet. Can it go into 128? No, it cannot. Can it go into 64? Yes, it can. So that's a 1. Is the remainder equal to or greater than 32? No, it's not. 16? No, it's not. 8? Yes, it is. 4? It is. And then 2? No. And then 1? It is. Okay, so we talked about our binary for the third octet, right, is 0, 1, 0, 0, 1, 1, 0, 1. Okay, so now let's talk about the fourth one, 254. Okay, so can 254 go into 128? Of course. Now, is the remainder equal to or greater than 64? Of course. So is the remainder equal to or greater than 32? Yes, it is. 16? Yes, it is. 8? Yes. 4? Yes. 2? Yes. 1? No. Now, so the binary for 254 is 1, 1, 1, 1, 1, 1, 1, 0. So this is the reason why I built this app, is so that you can easily break down the understanding behind it. Now, the app isn't exactly the prettiest thing in the world. Don't get me wrong. Let's do another one. Let's do 10, and let's do 17. Let's do another one of 50, just something random, and let's do 68. Okay, we'll load that in there. That loads in the very bottom so we can keep track of it while we can talk about it, right? So then we're going to actually equate that. Now the first one, again, we've talked about this before. 10 is going to be 8 and 2, so 0, 0, 0, 0, 1, 0, 1, 0. All right, second octal, our octet, is going to be 17, which comes down here to 16. 16, obviously 17 is equal to or greater than 17, and then you come in here, that's a 1. The remainder is not equal to or greater than 8 or 4 or 2, but it is equal to or greater than 1. So the octal for that, the binary for that octet, is going to be 0, 0, 0, 1, 0, 0, 0, 1. Okay, and that's shown down here, right? So I'm just doing the equation based upon the PLC code that we currently have, right? So I took standard formulation, made the PLC code from the standard base 2 implementation of binary. So it's just very much a broken down thing. Instead of just doing this all on PowerPoint, I figured it was a lot funner to do it with an HMI app and a lot funner to do it with PLC code, because it is an ITO convergence, so it is more or less, let's use the tools that we have. Let's talk about the third octet, right? That's a 50. And 50 is not equal to or greater than 128, 64, but it is equal to or greater than 32, and the remainder is equal to or greater than 16. So that's a 1. Equal to or greater than 8, no. Equal to or greater than 4, no. 2, yes. So the binary for the third octet, which is 50, is going to be 0, 0, 1, 1, 0, 0, 1, 0. Now the last one is 68. Okay, 68 is the fourth octet, right? So if I were to come in here, you can see that that's the reason I highlighted off of that, so because it depletes these out when I'm done. So the fourth octet, right, is going to be 68. So 68 into 128, nope, but it can in 64. So that's a 1. Is the remainder of that equal to or greater than 32? 16, 8, Nope, it's not. Is it equal to or greater than 4? Yes, it is, and that finishes that out. So that was the third or the fourth octet in that. For the number 68 is going to be in binary form, is going to be 0 1 0 0 0 1 0 0. Now hopefully this is very much an educational thing, because again, when it comes down to it, I want you to understand the way the math is done. It's the way the math is done that really is an enlightening tool, right? If anything, there's anything you can remember in the way things are, it's that binary is a base 2 system. So it's the power of 2, right, on each one of these. That's the reason it escalates up every time. And then once you understand that too, you can take this above and beyond and go into subnetting as well. But when it comes down to it, I want you to understand the base principle of IP addresses, and then understand how to do the math behind that, right? So 192, the reason we use a 192 example is 90% of stuff we get from Rockwell is a 192 coming out straight out the box anyway. So when it comes out, we want to understand the way that we can break down the math behind that. And that's what we did here, right? That's what we did in this app. That's what we did in this PLC code, right? So I'm just doing each octet, right? I'm doing all 4 of them when they enter them in, and then loading them in. All the code is basically repetitive, real simple, real easy. It's just a real IP address binary, right? That's what I called it, and the HMI app as well. So with that said, hopefully that was educational and showed you a lot about how to calculate and formulate binary, and showed you exactly what binary is and the IP address as well, as far as each octet, and how to actually determine the binary of that octet. So that gives you the full form of the actual binary address that goes talks through your computer, right? That's as simple as it is in a class C environment. So again, when it comes down to it, I just wanted to give you a good solid understanding of that. Hopefully you got a lot out of that. If you need to, go back and watch it again. But again, when it comes down to it, we'll see you guys on the next one.